Good morning, students. I hope all of you will be fit and fine. Yesterday, we have done the lecture which was based on the acids. Now, let's start with the next topic that are bases. What are bases, first of all? Bases is either a metallic oxide or a metallic hydroxide. Two things are there. Yesterday I have, I think, given in the starting of the lecture that the presence of oxide and hydroxide will be there in the bases, or ammonium hydroxide which react with the hydronium ions of an acid to form salt and water. It means bases, again repeating, presence of oxide and hydroxide will be must in case of the bases. Example of bases: copper hydroxide, copper oxide and magnesium hydroxide. Here I am taking example of copper oxide, that is a metallic oxide react with the acid, and there will be a formation of a metallic chloride with the water. Next one, metallic hydroxide, that is a magnesium hydroxide react with the sulfuric acid to form magnesium sulfate, that is a metallic sulfate with a water molecule. It means when the metallic oxide or hydroxide they are combined or reacted with the acid, there will be a formation of the either metallic chloride or metallic sulfate in above two examples with the water molecule. Now next term is your basic oxide, because at the starting I told you there is a presence of a oxide. Now we are doing the detail of the basic oxide. It is a metallic oxide which contain the ions of oxide. Again the oxide is coming O2 negative and react with an acid. Again the repetition is there to form salt and water. It means whenever the reaction of the acid and base is there, then there will be a formation of salt and water. I am taking another example, but here at last some changes will be there. We have to judge it whether the lead 4 oxide PbO2 is your metallic oxide or not, or it is a metallic, if it is metallic oxide, whether it is base or not. PbO2 react with the hydrochloric acid, there is a formation of a lead chloride with chlorine and water molecule. This extra chlorine is coming in this reaction. Above we have studied that only there will be a formation of salt and water. But here chlorine is also forming. It means it is not a base. PbO2 is not a base because it is not yielding the salt and water. It is yielding salt, water and something extra. Is it clear, students? Now, basic hydroxide, as the name indicate, basic hydroxide means there should be a presence of hydroxide. It is a metallic hydroxide which contain hydroxides and with react with an acid to give salt and water. Repeating again that the repetition is going on, that what is there, the presence of the hydroxide is there. And for example, hydroxide, check it, OH is a hydroxide, OH again hydroxide, sodium hydroxide and aluminium hydroxide is there. Reaction of this one, sodium hydroxide react with the hydrochloric acid, there is a formation of salt and water. It means our definition is correct. It is combining with the above definition. That means the NaOH is a appropriate basic hydroxide. Now the next term, that is alkali. Bases without alkali are impossible. What are alkali? Those bases which are soluble in water are called alkali. I am repeating. Those bases which are soluble in water are called alkali. When they are when they are soluble in water and when we are dissociating them, there will be a formation of positive and negative ions. Positive ions, that will be of your metallic ions, and your negative ion may be your oxide or hydroxide. This hydroxide will turn red litmus blue, that is the indicator. It will turn red litmus blue. And if it is turning the red litmus blue, it means it is basic in nature. After that, a single statement is there. All alkali are bases, very important statement, but all bases are not alkali. It means that whenever the bases are there and if they are soluble in water, then they are alkali. But all bases, it is not compulsory that the all bases might be soluble in water or may possible they are insoluble in water. It means the two conditions are there. If it is soluble in water, then it is alkali, and if it is not soluble in water, then it is bases. Here I am taking example ferric hydroxide FeOH thrice, cupric hydroxide Cu, compound of the Cu hydroxide. Both are the bases, but they are not alkalis, means they are water insoluble. Coming further with the examples sodium hydroxide, calcium hydroxide and ammonium hydroxide. Sodium hydroxide, potassium hydroxide, they are strong alkalis. Calcium hydroxide, ammonium hydroxide, they are not strong alkalis, they are weak alkalis because the ion furnishing are lesser as comparison to the sodium hydroxide. Now the classification of the bases. Bases are being classified. Number one, first classification, that is based on your strength. Strength is based on the concentration of hydroxide ion. It is again of two types, strong alkali and weak alkali. Above we have done the detail. Coming to the basis of the classification, which is based on your acidity. It is again based on the number of hydroxide ions. Here the number of hydroxide ions are there. Above it was the concentration of hydroxide ion. Here monoacidic base. Monoacidic means only one OH will be there. NaOH only one OH, KOH only one OH. OH will be in number, it will be 1. Diacidic 2 OH, OH twice, check it in the formula. OH twice, 2 OH is there. Check the reaction. In the reaction again, O2, OH twice are there. It means if the number is 2, then it is diacidic. Triacidic, that is aluminum hydroxide, 3 hydroxide ions are there. It means it is triacidic in nature. It means the number of hydroxide ions we have to check it here. Next topic is coming the preparation of bases. How we are preparing it. As we have done in the acid, the same procedure is going here. First of all, from the metals, we are taking the reactive metals or active metals. Treating with the oxygen, there will be a formation of the sodium oxide. That is base, means water insoluble. By the action of water on the soluble metallic oxide react with the water and there will be a formation of alkali. Alkali, sodium hydroxide is there because it is water soluble. Next is by the double decomposition. Under the double decomposition, We are taking the salt solution, ferric chloride, treating with the sodium hydroxide, formation of what? Basic hydroxide. Check this one. It is the arrow down. It means the precipitates are forming here. And there will be a formation of a salt. Means here the hydroxides are forming by the combination of the salt solution with the base. Next one, by the action of water on the reactive metal. When the reactive active metal we are taking here, treating with the water, formation of the sodium hydroxide with the hydrogen gas. Hydrogen gas is coming here, it is observation of that one. Next, by the action of the oxygen on metals sulfide. Metal sulfide here we are taking two examples, zinc sulfide and lead sulfide, treating with the oxygen, and there will be a formation of the zinc oxide with the lead oxide with the different. Again observation will be the different, and here the sulfur dioxide gas is coming. Here we have to put the arrow, sulfur dioxide gas, put that arrow here, sulfur dioxide gas is forming. By the decomposition of the salt, means here the salts are going to be decomposed, but it is a property of not all the salts will decompose. Some will decompose and some will not. Those who are decomposing, they will be forming the oxide and hydroxide, but those who are not decomposing, they will not show this reaction. Calcium carbonate, by heating it will decompose and there will be a formation of calcium oxide with carbon dioxide gas. Sodium and potassium carbonate, they don't decompose. It means they are not, if they are not decomposing, then they will not show this test. Calcium nitrate, treating with, again, decomposing, heating sign should be there. We are showing the heating sign and there will be a formation of calcium oxide with nitrogen dioxide, brown gas with oxygen, colorless gases there. Sodium potassium nitrate, again don't decompose on heating. It means again that test is not for them. Ammonia react with the water. All you know, whenever the ammonia is always in the gaseous form. Ammonia react with water, there will be a formation of the ammonium hydroxide, that is a weak alkali. All are the preparations. Now I am coming to the physical property. It had the bitter taste. With the effect of the litmus, it will turn red to blue. With methyl orange, the methyl orange will turn to yellow. With phenolphthalein, the colorless to pink will be there. But all these are based on only alkalis because they are water soluble, and for the indicator the water is essential. Then only the ion furnishing will be there. Next property, next physical property of this one is it had the slippery in touch. They are strong electrolyte, shown mild corrosive action, means they show the burning taste. Some stains are coming, they show the burning taste. A slight burning is there. If they are being on your skin, then the slight burning is there. Chemical properties, for the chemical properties, I am taking here the strong alkali, treating with the carbon dioxide. Carbon dioxide will be in the gaseous form. There will be a formation of the sodium carbonate and the water. Carbonate means the metal carbonate is there. Calcium hydroxide, that is your weak alkali, treating with the acid, formation of the calcium chloride with the water molecule. Copper sulfate, treating with ammonium hydroxide. Metals sulfate, your what? Non-metallic sulfate is forming with the copper hydroxide. It is in the PPT form. The color of the precipitate will be the pale blue. Zinc sulfate, treating with the sodium hydroxide. Your sodium sulfate is forming with the zinc hydroxide with PPT, that is a glutinous white. Ferrous sulfate, treating with the sodium hydroxide. Sodium sulfate is forming with the ferrous hydroxide. The color of the PPT is dirty green. All these observations are very important. Kindly note it down, mark it important. Here, zinc, aluminium, and lead, three things, three elements are there before you. They all are the amphoteric in nature. They dissolved in sodium hydroxide and KOH. If they are dissolving in the sodium hydroxide and potassium hydroxide, it means they are giving the different test. Like zincates are forming, that we will do further on. The reaction is there in your book, you can check it there also. Here student, one thing I will explain you, 1 type, 1 example I have taken from 1 type. You can recheck your book. More examples are there regarding all these preparation. Kindly all these preparations and properties, kindly go through it thoroughly, and if any doubt will be there, kindly discuss with me. Next one, ammonium chloride, white solid, treating with a strong alkali. We are heating it, it will decompose, and there will be a sodium chloride, water, and ammonia is forming. Ammonia, pungent choking smell. It is showing pungent choking smell. All are for the chemical properties. I am repeating. More examples are there in your book. Kindly go through it, and if any doubt is there, kindly you can give your message on your end tab. At last, the uses table is there in your book. The table number is 3.334. I'm showing this one. This one table, this table, general uses of some gas bases. You have to learn it thoroughly. It is very important, and the question can be there in your exam. That's all for today. We have finished with the basis. Tomorrow I will give you the lecture on the acidity and alkalinity. Thank you. God bless you all.